Here's a question that should disturb you more than it probably does. Right now, at this exact moment, you are the product of 12 to 16 years of one of the most sophisticated behavior modification systems ever built. You sat in rows, you spoke when told, you memorized what you were given and forgot it the moment the exam ended. And here's the disturbing part. You were told that was education. Over 1.5 billion children pass through this same system every single year. And the man who understood the deep structure of physical reality better than almost anyone alive, Richard Feynman, looked at this system and called it, in his own words, a disease. Not a flaw, not a design problem, a disease. By the end of this video, you will understand exactly what he meant, and you may never look at a classroom, a certificate, or your own thinking the same way again. Let me start with what you believe education is. You believe it is the transfer of knowledge. A teacher has information. You receive information. You understand it. You grow. That is the story. That is the clean, beautiful story in every school prospectus, every graduation speech, every well-meaning parent's heart. But here's the thing. That is not what happens. That is not even close to what happens. Here's what actually happens. A child is born, and that child, from the very first stirring of awareness, is a learning machine, not a metaphor, a literal, biological, evolutionary learning machine. Babies acquire language, the most complex symbolic system the human mind has ever devised, without a single grammar lesson, without a textbook, without anyone writing vocabulary words on a board. They do it through curiosity, through play, through relentless, joyful, exhausting trial and error. By age 5, the average child asks approximately 300 questions per day. 300. That is the natural resting state of a human mind. Then something happens. They go to school. By age 10, that number has dropped to roughly 30 questions per day. By the mid-teens, it collapses further. Not because the universe has become less strange, not because every question has been answered, but because those children have learned something far more powerful and far more damaging than any fact in any curriculum. They have learned that asking questions is dangerous, that the wrong answer costs you, that uncertainty is a weakness to be hidden, not a doorway to be walked through. And here is the first thing I want you to hold in your mind right now. If school is designed to educate, why does education so reliably dismantle the very instinct that makes learning possible? Think about it. Don't let it slide. Hold that question, because the answer is going to genuinely unsettle you. But here's the thing. This is not a philosophical musing. This is measured. This is in the data. In 1968, a researcher named George Land was commissioned by NASA to develop a creativity assessment for identifying innovative scientists and engineers. The test was rigorous. It was validated. It was used to select some of the most extraordinary minds NASA had access to. Then Land, almost as an afterthought, administered the same test to 1,600 children. The results, when he published them, should have triggered an immediate national emergency. 98% of children aged 3 to 5 scored at genius level for divergent creative thinking. 98%. By age 10, 30%. By age 15, 12%. By adulthood, by the time you and I emerged from the far end of our education, 2%. 2. The same system that was supposed to make us more capable had, by the single most rigorous measure available, made 96% of us creatively dysfunctional. And yet, we called it progress. We called it civilization. Now, let me take you into Feynman's mind for a moment, because there is a story, one specific story, one he told himself in his own voice, that I think about more than almost anything I've read. Feynman taught physics at Caltech for decades. He won the Nobel Prize in 1965. He was, by every account, one of the most genuinely, incandescently curious people who ever lived. But he had a specific contempt, not a mild discomfort, a contempt for what he called cargo cult science and what he considered the educational machinery that produced it. One evening, walking through the Caltech campus, a student approached him, excited, textbook under his arm. He'd just passed his optics exam. He said, "Professor Feynman, I've got it. The light reflects at an angle equal to the angle of incidence." And Feynman looked at this bright, grade-achieving student, and asked him one question. "What does that look like? Show me with your hands." The student couldn't do it. He had the words, he had the formula, he had passed the test. He had, by every measurable standard the institution possessed, demonstrated competence. But he had no picture, not even a vague impression. He had never, not once, actually imagined what happens when a wave of light hits a flat surface. Feynman called this knowing the name of something versus knowing something, and he said the confusion between the two was one of the most dangerous intellectual habits a civilization could cultivate. Let me take stock, because I want to be precise about what we are charging the system with. Here is the charge sheet against modern education. It rewards memorization over understanding. It penalizes wrong answers instead of interrogating wrong thinking. It teaches children that intelligence is a fixed property. You either have it or you don't. It replaces intrinsic curiosity with extrinsic grades. It trains the young to wait for instructions rather than generate their own questions. It measures the entire value of a human mind on a single metric, timed exam performance that correlates poorly with almost every outcome that genuinely matters in a human life. And it does all of this during the most neurologically sensitive, most structurally malleable, most unrepeatable period of human brain development. Every single one of these features, every one. The same root cause, the same explanation. The system was designed for compliance, not for curiosity. But what I'm about to show you in the next section, and I want you to stay with me here because this is the part most people never get to, completely changes the way everything I've just said makes sense. Because the damage doesn't stop at behavior. It doesn't stop at beliefs about intelligence. It goes much further. It goes all the way down to the structure of your neurons. And once you've seen it at that level, you'll understand why this is not a political problem or a funding problem. It is a neuroscience problem. Let me explain this the way I'd explain it to a bright 12-year-old. Because when you can do that, when you can strip a thing down to its bare mechanism and hand it to someone who has no jargon, no preconceptions, and no patience for waffle, that is when you know you genuinely understand it. That is the Feynman standard. Your brain has a feature, a colossal, extraordinary, underappreciated feature. Scientists call it neuroplasticity, the brain's capacity to physically rewire itself in response to experience. Every time you encounter something genuinely surprising, every time a question forms in your mind that you can't yet answer, your neurons begin forming new synaptic connections. Synapses, those tiny electrochemical gaps between brain cells where signals leap, grow stronger with use. The physical architecture of your brain reshapes itself in real time around the act of wondering. Now, here's what neuroscience tells us about how that wiring happens best. Curiosity activates the brain's mesolimbic reward circuit. Specifically, it triggers the release of dopamine, the neurotransmitter most people associate with pleasure, but which is more precisely a signal of anticipated reward, into the hippocampus, the brain region most responsible for encoding long-term memory. A 2014 study from the University of California, Davis, led by neuroscientist Matthias Gruber, placed participants in an fMRI scanner and asked them trivia questions. Some questions were ones the participants found genuinely curious, others bored them. The finding was extraordinary. When curiosity was activated, the hippocampus lit up with unusual intensity. The brain wasn't just processing information, it was in a state of heightened receptivity. And here's the kicker. The participants didn't just remember the answers to the questions they were curious about. They remembered everything they encountered during the curious state. Unrelated images, incidental details, things that had nothing to do with the topic, with dramatically improved recall. Think about what that means. The brain is designed by millions of years of primate evolution, by the entire arc of human survival, to learn with voracious, almost alarming efficiency when it is curious, and to learn almost nothing of lasting value when it is bored, anxious, or performing under compulsion. Curiosity is not a nice decoration on good teaching. It is the biological mechanism. It is the switch that turns the memory system on. Now, Let me show you what standardized education does to that switch. It takes a child whose dopamine system is flooded every time they discover something new and places them in an environment where the questions are predetermined, where the answers are already known by the person asking them, where the speed of discovery is set by a printed curriculum rather than by the child's own momentum, and where the social cost of a wrong answer, the humiliation, the red mark, the grade reduction is immediate, public, and personal. What does a brain do under those conditions? It does exactly what it evolved to do under environmental threat. It narrows. It defaults to the most energy-efficient, lowest-risk strategy available. It memorizes sequences. It reproduces expected patterns. It stops generating novel connections, because novel connections require the courage to be wrong, and being wrong in this environment is dangerous. The brain under exam conditions is not learning, it is surviving. Copper, iron, mercury, silicon, gold, place any of them under sustained environmental threat, and their properties change. They contract, they harden, they stop flowing. Your brain, under the sustained social threat of graded performance, does the same thing, and yet we call this education, for 1.5 billion children, for well over a century. But wait, there is more to this story, because what I've described is the effect on conscious learning behavior. What comes next is the effect on something you cannot observe from the outside, something that has been quietly shaping the rest of your adult life without you knowing it. Don't go anywhere. Let me take you one level deeper. In 1998, psychologist Carol Dweck of Stanford University, working with Claudia Mueller, published a paper that should be required reading for every person who has ever set foot in a school, as a student, a teacher, or a parent. They ran a simple, devastating experiment on hundreds of fifth-grade children. Here's how it worked. The children were given a set of moderately difficult puzzles. They all performed reasonably well. Then, and this is the exact fulcrum of the experiment, each child was given a single sentence of feedback. Half the children were told, "You must be very smart." Half were told, "You must have worked very hard." One sentence, delivered once. Then Dweck gave both groups a harder set of problems. The children praised for being smart, for their innate intelligence became immediately risk-averse. They chose easier problems when given the option. When asked how they'd scored, a significant proportion lied. When they failed the harder set, they stopped trying. When told the harder problems were designed for older students, many of them interpreted this not as a neutral fact, but as evidence of personal inadequacy. Their entire sense of self had been fused to a label, and the moment that label was stress-tested, the self cracked. The children praised for effort responded in the opposite direction. They chose harder problems. They persisted longer. They reported enjoying the challenge more. They improved their performance on subsequent tasks. They had been given something far more powerful than a compliment. They had been given a model of intelligence as a process rather than a possession. Let me pause here, really pause, because what Dweck discovered, what she called the fixed mindset versus the growth mindset, is not simply a useful framework for teachers. It is an exact description of what the standard school system, for the majority of children, reliably and systematically produces. When you sort children into grades, when you stream them by measured ability, when you label them gifted or remedial, when you define their worth through performance on a single standardized examination, you are not measuring intelligence. You are manufacturing a fixed identity. Imagine a dance hall, a normal dance hall, late on a Friday night. In a normal dance hall, people drift in and out. They pair up loosely. They move around. Nobody's especially attached to their partner. The social bonds are light, flexible, transient. If someone steps on your foot, it's no big deal. You just find someone else. You keep dancing. Now imagine a different kind of dance hall, one where, the moment you walk in, you're assigned a number. And that number, stamped on your wrist from the first evening you arrive, visible to everyone, tells every person in the room what kind of dancer you are. The 4s stick together. The 9s don't dance with the 3s. The 1s spend the night by the wall. In this dance hall, nobody is loose. Nobody takes risks. Nobody asks someone new to dance because the cost of rejection is now identity level, not just social. You have to work very hard to separate anyone from the weight of that number. That is what a graded, ranked, labeled school system does to the social architecture of learning. And here's where it gets genuinely disturbing. 94% of American adults, when surveyed, report that they are not a math person or not a science person. 94. Think about that. Not that they find math difficult, not that they prefer other subjects, but that mathematical thinking is not something they are, not a capacity they possess. A permanent, identity-level exclusion from an entire domain of human understanding, adopted during childhood, carried into adulthood like a stone in a shoe. What was done to 94% of those people during the years when their brains were most plastic, most hungry, most ready to find genuine pleasure in the structure of the universe? The answer is not complicated. They got a bad grade, or a harsh comment, or a teacher who was exhausted and underpaid and moving through 30 students a day, and the brain, in its extraordinary efficiency, filed the experience not as I didn't understand that particular concept on that particular day, but as I am not the kind of person who understands this. That is not a minor skill. That is a rare and catastrophic one. We are, each of us, a biological learning machine that was handed over at the age of 5 to a system that was never primarily designed to unlock that potential. We went in asking 300 questions a day. We came out asking for instructions. And somewhere in those years between 5 and 18, we lost something, quietly, incrementally, without ceremony, that most of us have been trying to recover ever since. That is not a small thing. That is a civilizational wound. But if you think that is where the damage ends, I need you to stay with me. Because what I'm about to show you in the next layer is the part that most people never fully confront. It concerns something you use every single day, something invisible, something that is quietly, persistently shaping the quality of your thinking right now as you watch this. And if you've made it this far, you are exactly the kind of person who needs to hear it. Here's a fact that should bother you more than it probably does. In 1885, a full century before neuroscience had the tools to see inside a living human brain, a German psychologist named Hermann Ebbinghaus sat alone in his Berlin study and did something that no scientist before him had thought to do. He memorized lists of nonsense syllables, hundreds of them. Meaningless strings of consonants and vowels, stripped of any emotional content, any narrative, any curiosity value whatsoever, precisely the kind of content that school exams are built on. Then he measured with meticulous obsession how quickly he forgot them. He ran the experiment on himself repeatedly for years. He plotted the decay curve, and what he found was so mathematically clean, so relentlessly consistent, that we still call it by his name 140 years later, the Ebbinghaus Forgetting Curve. Within 20 minutes of learning something, you forget approximately 40% of it. Within a day, 60% is gone. Within a week, 90% has vanished. And the things memorized specifically for an exam, encoded under pressure, under the cortisol spike of social threat, with no curiosity attached, those decay fastest of all. The brain is not being lazy. It is being ruthlessly efficient. It is discarding what was never connected to anything that mattered. Now, let me show you what this means at the scale of a human childhood. 13 years of compulsory education, roughly 15,000 hours. In those 15,000 hours, a child is fed a systematic, carefully sequenced quantity of content, the dates of wars, the classifications of phyla, the chemical formula for glucose, the rules of trigonometry, the literary devices in poems by people who died before their grandparents were born, the names of rivers and countries they will likely never visit, how to identify the type of rock from a photograph, how to conjugate irregular verbs in a language they stopped practicing the day the exam ended. How much of it do you remember? Be honest. Right now. Be genuinely honest with yourself. Because a 2017 study published in the Journal of Educational Psychology tracked students across a 4-year period and measured retention of formally taught curriculum content 12 months after graduation The number is, and I want to be careful here because I want to let this land properly, fewer than 10% of formally taught content was retained 1 year after leaving school. Fewer than 10%. Not retained for a career. Not available when it was actually needed. Gone. This is not a failure of effort. These were not lazy students. This is the Ebbinghaus curve operating exactly as biology predicts. Information without emotional resonance, without curiosity as its carrier frequency, without application in a context that the learner cares about, does not encode into long-term memory. It cannot. The hippocampus has no evolutionary mandate to retain it. And yet, we built an entire civilizational sorting mechanism on this model. We distribute university places, career access, social status, and lifelong self-perception based on a child's ability to retrieve this information under time pressure, in silence, in a room full of strangers, using a pen, during a 2-hour window that represents approximately 0.02% of their educational lifetime. And then we wonder why so many brilliant, capable, intellectually hungry adults spend their lives feeling like frauds, like they scrape through, like they're performing competence rather than possessing it. Let me build this up carefully, because here is where it gets not just disturbing, but genuinely catastrophic. Not for one person, for everyone. Imagine a generation, not a metaphor, an actual generation of real people who went to real schools between the 1970s and the 2020s, raised to optimize for grades rather than for understanding. The first consequence, they learn to perform competence rather than develop it. The second, they become profoundly uncomfortable with uncertainty, because uncertainty is the state in which failure becomes possible, and failure is how you got labeled, sorted, and dismissed. The third, they stop taking intellectual risks, because every creative leap, every unconventional idea, every answer that might be wrong is a threat to the identity they've spent years constructing. The fourth, they carry this entire neural architecture into adult life, into their careers, their relationships, their parenting, and they pass it on. They praise their children for being smart. They celebrate the grade, not the process. They watch their children's curiosity narrow, year by year, and they call it growing up. And it gets worse, because the prefrontal cortex, the region of the brain most responsible for abstract reasoning, creative synthesis, long-range planning, the ability to hold two contradictory ideas simultaneously and not panic, is also the region most sensitive to chronic social stress during development. Sustained, repeated, evaluative stress during childhood doesn't merely modify behavior, it modifies the microstructure of neural connectivity. The connections that should have been reinforced by curiosity-driven exploration, by the beautiful, metabolically expensive act of following a question wherever it leads, were instead reinforced in the service of threat response, monitor, comply, produce the expected output, survive. This is not poetry, this is fact. And the reason so many adults feel as though their most creative, most original, most genuinely intelligent thinking happens not at work, not in formal settings, but in the shower, on a long drive in the 10 minutes before sleep, is not a personality quirk. It is because those are the only moments in the day when the performance anxiety circuitry is finally quiet enough for the default mode network, the brain's associative narrative creative system, to come back online. You pull the thread of that observation all the way down to the layer of synaptic pruning, and then down to dopaminergic conditioning, and then down to the reward architecture that 13 years of grade-based schooling installed, and then all the way to the fundamental design principle of mass education as it was codified in the 19th century. You pull that thread and it goes all the way down, all the way to the quantum of who you currently believe yourself to be. And I find that poetic and devastating in equal measure. The most familiar institution in your entire life is still teaching you something, not what it intended to teach you, but something more important, the extraordinary resilience of curiosity and the extraordinary cost of suppressing it now. Let me zoom back. We've been at the level of neurons and cortisol, and forgetting curves for a while, and I want to bring this back to you, to your actual life, to your actual experience. Think about the last time you were genuinely, completely, helplessly absorbed in learning something. Not because you had to, not because a deadline was looming, not because a line manager was watching, but because you could not stop, because one answer opened into two questions. And those two questions opened into four, and you looked up, and 2 hours had passed, and you felt, I don't know how else to say this, you felt like yourself, lit up, alive in a way that ordinary Tuesday afternoons don't usually permit. When was that? Be specific. Try to remember. Maybe it was a Wikipedia spiral at midnight that began with a question about the Roman Empire and ended with you reading about the evolutionary genetics of the domestic cat. Maybe it was a podcast in the car. The host said something, and something inside you said, wait, and you rewound it. And the second time you heard it, something clicked that had never clicked before. Maybe it was a book you started intending to skim, a book that turned out to be the kind that makes you miss your stop on the train. That feeling, that absorption, that state, that is not a distraction, that is not procrastination. That is your brain doing what it was built to do at full capacity, with all the lights on. That is the Matthias Gruber dopamine hippocampus circuit firing exactly as evolution designed it to fire. That is the machinery of genuine learning running hot and clean in the body of an adult who was told for 13 years that learning looks like silence in a room with a clock on the wall. And here's what I find when I sit with that image. Really sit with it. Most of us have that experience in spite of our education, not because of it. The curiosity that pulls you down those rabbit holes was not given to you by school. It survived school, battered, redirected, driven underground for years, but alive, still alive. And I find that remarkable, I genuinely do. That the human impulse to understand, to ask why, to follow the question wherever it leads, regardless of whether the answer is useful, or graded or approved, that this impulse is so ancient, so deeply wired into the architecture of the species, that 12 years of systematic institutional grade optimization cannot extinguish it. It cannot. It can narrow it. It can redirect it. It can bury it under performance anxiety and credentialism and the desperate daily theater of appearing competent. But it cannot kill it. Richard Feynman knew this. He talked about it with a warmth that surprised people who knew him only through his physics. He wrote, I learned very early the difference between knowing the name of something and knowing something. He didn't learn that distinction from Caltech. He learned it from his father, Melville Feynman, a uniform salesman with no formal scientific education, who used to take young Richard into the Catskill Mountains on weekends and point at things, a bird, a rock, a pattern in the bark of a tree, and he'd ask, what do you notice? What's strange about that? What do you think is actually going on? Not what is it called, what is going on. Not can you reproduce the label, can you model the mechanism. Those two questions are the distance between the education system we have and the education system we could have. And those, Feynman believed, are the two most important tools in all of science. The refusal to be satisfied with a name and the habit of asking what is actually happening. He carried those tools for his entire life. Not from Harvard, not from MIT, from a walk in the woods with a man who sold uniforms and loved questions. Let me be honest with you, I think about that story a lot. I think about how much of what matters most in intellectual life is not acquired in formal settings, but stolen, quietly, almost illicitly, from moments when the structure was temporarily suspended, a teacher who went off curriculum, a book you read under the desk, a conversation that went somewhere nobody planned, a question you asked that the teacher couldn't answer, and which, because of that, because of the sudden crack of acknowledged uncertainty, became the most memorable moment of the entire year. We are, each of us, a briefly arranged collection of extraordinary neurons that spent the first years of our lives asking 300 questions a day. That is the natural state of a human mind in contact with reality. 300 questions a day. And a system, well-intentioned, underfunded, structurally misaligned, managed to reduce that to 30, then to almost 0, and called the reduction maturity, called it discipline, called it being ready for the real world. The real world, as it turns out, is made almost entirely of questions that nobody has answered yet. And the people who do the most important work in it, the researchers, the designers, the entrepreneurs, the artists, the scientists, are, without exception, the people who never fully stopped asking, the people whose curiosity survived, the ones who kept the child's habit of looking at something ordinary and refusing to accept that ordinary meant understood. That is who Feynman was. That is who you were before the system got its hands on you. And here is what I want you to hold on to as we move into the final part of this conversation. The question is not whether you can become that person again. The neuroscience is unambiguous. You can. The question is whether you're willing to accept that the process of unlearning, of dismantling the performance-first, compliance-first wiring is itself the most important education you will ever undertake. So, what does this mean for you? Let me be honest with you. I'm not going to tell you to burn your degree or denounce your teachers or declare the whole enterprise fraudulent. That is not the point. Most teachers are doing something genuinely noble under conditions that are genuinely impossible. The problem is not the people. The problem is the architecture. And knowing the architecture, seeing it clearly, understanding its mechanism, is the beginning of the only response that actually works. Here is the most remarkable thing about the human brain, and I want you to really hear this. It is not finished at 18. It is not finished at 30. It is not finished at 50. Neuroplasticity, real, structural, measurable neuroplasticity, the physical growth of synaptic connections, continues throughout life. A 2016 study from Harvard's Center on the Developing Adult found that significant neural rewiring continues well into the mid-20s, and that meaningful synaptic growth persists in reduced but real form for decades beyond that. You are not locked. You are not sentenced. Whatever the system told you about who you are and what your mind is capable of, those were measurements of a child under sustained cortisol load. They were not a verdict on the architecture of your intelligence. Let me give you 5 things, not a curriculum, not a prescription. 5 shifts in orientation, 5 ways of relating to learning that the evidence suggests will rewire your brain back toward the state it was in before anyone started grading it. First, replace performance with curiosity as your primary orientation. When you approach any new subject, your only assignment is to find the one thing about it that strikes you as genuinely strange or surprising or slightly maddening, not to master it, not to pass anything, just to let genuine interest form. The neural encoding will follow curiosity. It always has. It was doing it long before school taught you to ignore it. Second, use what Feynman called his core technique. Take whatever you believe you understand and try to explain it out loud to an imaginary 12-year-old, using only your own words and your own pictures. No borrowed jargon, no copied phrases. The moment you can't continue, the moment the explanation collapses, you have found the exact location where your understanding is hollow, not as a failure, as a gift, as a precise map of where to go next. Third, learn to be wrong in public and let it be unremarkable. This is the hardest rewiring of all because 13 years of institutional conditioning fuse the experience of being wrong with the experience of social threat. That fusion lives in your nervous system now, not just in your beliefs, but wrongness, to a genuinely scientific mind, to Feynman's mind, to Darwin's, to Curie's, is not failure. It is the most valuable data available. It tells you exactly where your model of reality diverges from reality. That divergence is not a reason to feel small. It is a reason to feel curious. It is the beginning of understanding. Fourth, read deliberately outside the borders of your expertise. Pick up a book that has nothing to do with how you earn a living, not a self-help book, not a productivity guide, something genuinely alien to your usual domain, the history of color, or the mathematics of braiding, or the way 14th century farmers understood the passing of time. The brain forms its most generative connections at the edges between unrelated domains. That is not a metaphor. That is where creativity, in the strict neuroscientific sense of the word, actually lives. Fifth, ask the child's question, the one that sounds too naive, the one that sounds like it should already have been answered. Why does anything spin? Why do we cry when we're happy? Why does time feel faster as we age? These are not simple questions. These are the questions at the current frontier of physics, neuroscience, and philosophy. The fact that they sound simple is not a sign that the answers are known. It is a sign that most of us stopped asking. And that question, whatever question just formed in your mind as I say that, is the greatest gift the universe has ever handed you. Don't grade it. Don't look up the approved answer. Just sit with it for a moment. Let it open. That's the whole point. Let me take stock of where we've been. We began with a number. 98% of children at genius-level creative thinking by age 5, 2% remaining by adulthood. We walked through the Neuroscience of Curiosity, the Gruber study, the dopamine hippocampus circuit that school systematically bypasses. We sat with the Ebbinghaus Forgetting Curve, and the honest implication that the vast majority of what those 15,000 classroom hours delivered is simply gone. We looked at Carol Dweck's Stanford research and understood how the act of labeling a child smart manufactures the very rigidity that makes them fragile. We followed Feynman's thread, from the student who couldn't show him what light looked like, all the way back to a walk in the Catskills with a uniformed salesman who loved questions. And at the bottom of all of it, pulled all the way down through behavior, through neuroscience, through the architectural history of mass education, we found the same thing: a system optimized for compliance, operating on the most neurologically sensitive years of a human life, producing compliant people who quietly miss the curiosity they once had and aren't entirely sure they're allowed to reclaim it. But no, that is not the end of the story. Here you are, still asking questions, still curious enough to spend 35 minutes examining the machinery of your own mind. That curiosity was never destroyed. It was only buried, and everything in this video has been, in the most literal sense, an excavation. Now I have a question for you. Think back to one moment, one subject, one discovery, one afternoon, when learning felt the way it was always supposed to feel, not performing, not memorizing, just genuinely, unreservedly understanding something that shifted the way you saw the world. Leave it in the comments. Tell me exactly what it was, because those moments are the most important data we have about what a human mind can do when nobody is grading it. Thank you for thinking about this with me. A classroom is a room. A curious mind is an education. And the question of what your mind could still become, that question, sitting quietly in you right now, is the most extraordinary invitation the universe has ever offered.